Our next speaker, Julian, said he's not very exciting as a person. He hasn't got many things to say. He has children, and I can totally empathise with this. It's like children go to bed and I watch TV. That's pretty much it.
Pretty much how it goes.
That's how it goes, unfortunately. But we are going to a party tonight.
No.
Oh no!
I'm going to go and pick up
really
my kids from school. Got the 4 o'clock. Oh no, 5. I've got 5:30 after school pickup.
Oh shit!
My turn.
All right. Well, he's not. He's not going to a party. Okay. But Julian is a lead developer at Envato.
Yep.
He has been a developer for almost over 20 years. 20 years.
Give or take, yeah.
Yeah, and he's been working with Ruby for 13. He's from Wellington.
Yes.
We love Wellington. And he's now in Melbourne, and he does do some things other than watching TV. He also runs the Elixir meetup.
Yes.
And that's a big thing.
It keeps me busy.
Yeah, it does. Anyway, he's going to give us a talk, and it's going to be great.
Yes.
And it's about escaping your framework, which is some pain that we all feel, right?
Sorry.
At one time or another. Welcome, Julian.
Okay. Sorry, just get this going. We've got a thing. Excellent. Yeah, as Mel said, I am Julian Doherty, and I am a lead developer at Envato. You can find me on the internet at MadLab on Twitter or juliandoherty.com. And yeah, I work at Envato. We are hiring at the moment. I think we've got a few roles going. If you're interested, go to careers.envato.com, or Brent is over in the corner there. And if nothing else, he's got some cool swag that he can set you up with. Also run, as Mel said, the Elixir Melbourne meetup. So if you're into programming in Elixir, come along, and we talk about some of the stuff I'm talking about in this talk, but kind of not so much. So what this talk came about from is, I'm going to say a famous Hollywood movie star contacted me. They're writing some code, they're making their own site. It's a cool startup idea, and they wanted some feedback. You know, how are they doing? How they're doing? I'm not allowed to say who it is, but I'm allowed to talk about the project. You might be able to figure out who it is along the way. So they sent me a mock-up of what the site looks like. It's going to be kind of like this, called. And I said, "Cool, thanks Overflow." They're not. No. It's pronounced T-Hanks Overflow. So what it is, it's a site where you can go and ask questions about a particular star and all the movies they've been in, and you can get points for answering those questions. I'm not allowed to say who this star is. So first thing I want to do, I said to this star, you need to go to somewhere to get the data because you don't want to type all this stuff in manually. So there's a site called themoviedb.org, and it's like IMDb, except it's community sourced, and it has most of the same data there. And it has an API you can use, which is the nice thing about it. That'll give you something that looks sort of like this. So you go and query person ID 31, who is maybe the person we're talking about, but I'm not allowed to say. And that'll give you back some data about this. So Forrest Gump is the most popular movie that this person has been in. So they're cool. They kind of thought, okay, cool, they've done enough. They've read some, articles on how to code. They've done, Rails blog in 15 minutes. They're ready to get hacked into writing some code. Okay, first thing is to import this data. So they're getting us get cracking. Let's write some code. Version 1 is going to be pretty quick and dirty. So let's see what they came up with. There's a lot going on here. I'm not going to read all through this, but there's things happening there. So I kind of went through and did pull request, feedback on this. It's like, well, there's a few things going on here. You've got an API key hard-coded in there. It's a Rails controller and everything is right there. There's no error handling. It's difficult to test. You can't reuse any of this. Difficult to debug. So you dig down into all that, and it's like, okay, cool. It's a good start, but we need to take this and kind of escape the framework. So we're too coupled to what's going on in Rails there, and that makes it hard to do anything. So how do we pull out stuff from there? So we're stuck in there. We want to get that out so we can reuse it somewhere else. First thing, we've got to pull it out of the controller. So we've got this controller there. All the logic is stuck right in there. So that's kind of an easy fix first up. So let's start off by grabbing that URL or the API key. We'll put it in the Rails configuration. It's nice and straightforward, and probably get that from the environment somewhere. If you do it that way, you kind of make it someone else's problem who works in the DevOps side of things. Encrypting secrets and stuff is really fun, and I love doing that. And then our controller itself becomes much simpler. So we've created a credit importer class, and we just call that. So we get our person ID, and we give it the URL that we're going to talk to, and then we call importer.import, and that'll go and tell us how many were inserted, updated, and how many errors there were. And that'll put some things in the flash to display it back to the user. Okay, that's cool. And then our code itself looks like this. So it's better. There's still a lot going on in here. It's basically a copy and paste to what we had before, take it out, put it somewhere else. It works. Still hard to test, and don't have any error handling. So we need to go further. Let's escape even more from what we've got. So errors are going to be a problem here. We have to fix up all these errors that we've got. So to start with that, we could have some stuff in there for if else, if this happened, or you could rescue exceptions and that'll work. But let's talk about our values here. Like, what values are we bringing to this work? And by values, I mean values. So there's a gem called Values by a guy called Tom Crayford. It's a little bit old. It's not maintained all that much, but it still works. And what it gives you is kind of like a struct in Ruby. So you tell it, I want to create a point class that just has an X and a Y coordinate, and that's immutable. So you can't change it. You can't mess around with it. It's a bit stricter than what struct gives you. If you do want to change it, it's like we've got a change point, you call a .with method, and you give it a hash of the arguments you want to change, and that'll create a copy of that thing and change the fields that need to be changed. So the original one is unchanged in this case. So I like this because it's immutable, so it lets us think about code in ways that don't change. Because if you're wanting to have code that's easier to reason about and it's changing under your feet, it gets weird and it gets harder to reason about. So once we've got that in place, then we can have some code in there that'll let us handle the errors a bit better. So let's just create a couple of utility values. So one for success, one for failure. And they both have like a success and a failure method on there. And this will wrap up a result or an error message, depending on what you're doing. We can use this in our code to abstract away all that logic. So where we handle this error is different from where it actually happens. And while we're at it, let's create another summary class for all the things that are going on. So when we go through that list of credits, it'll tell us how many were inserted new, how many were updated, and then there were some validation errors because the data is not quite matching what we've got in our database, and validation fails. And that's fine, it's not a fatal error, we're going to carry on. But we want to report that back up. And we can use that like this. So let's create a couple of methods here. Our celebrity is getting into this, and they thought, okay, well, cool, I can go in there and pull out fetch credits that'll go and do the HTTP call. And then we can inspect that response, and if it's a successful response, we'll return a success object with the response body. Or if it's a failure because it wasn't a 200 range status code, then we'll return a failure. Otherwise, if something goes really wrong, like a DNS lookup or the network goes down, then we'll catch that error that gets raised, and we can return a failure for that as well. And likewise for passing credit. So we get given a bunch of JSON. We don't know if that JSON is valid or not. If there's a problem with it and it barfs, we're going to have to go through and catch the error for that as well, and likewise return a failure object for that. So we'll also create a create or update title method. And this is kind of just taking that code, copying and pasting it, and taking it out of the flow of the main thing. So we can think about that a bit more easily. And really all this is doing is it looks up the database. Let's check if we've got a title that uses that ID from the internet database, or the movie database. If we do, we're just going to update the popularity and set the current time that it was synced at. If we don't have it, then we're just going to insert the thing in the database. And then we're going to update the item summary as well. So we're going to change the updated count or the inserted count or the error count, depending on what happens. In our thing that actually calls this is where we can handle that, or this is where we can actually bring that back. So the overall thing, when we're running through, we're going to import all the data. We're going to call fetch credits. Then we're going to, if we get a failure there, we're just going to return what the result was there. If that's okay, then we're going to go on to the next bit. We're going to try and pass the credits. So the JSON is going to come in, and we're going to try and make sure that that's okay. If that fails, we're just going to return the failure. Otherwise, we're going to go down into the next statement, where we're going to create a new import summary. And then we're going to get our past credits, get the result, which is in the cast field inside the JSON payload. And then we're just going to iterate over that with each. And for each one of those cast entries, we're going to create our update title, which is calling this method here we had before, and update the items, the import summary. And we're assuming that's all going to work because we've checked validation. I mean, the database could buff, things could go wrong, but we've handled all the things that we care about in terms of our application logic. Then we return a success object wrapping that. So this is better, but I'm still seeing the if-else pyramid of doom here. So it's going down a lot of layers. It starts at the top, goes down, 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 in. It's like down and right, down and right, down and right, and then back out, left and down. How can we clean this up? So I had our celebrity go away, do a bit of research on what you could do here. What other ways have we got to handle those things? So we need to escape that framework of the if-else. So the if-else keeps on going down, and we're going to be in that world of pain for a long time. So we've got to think about if something happens, then something else happens, what do we do in response to that? Yeah, this scene didn't test well with audiences. I don't think it made it the final cut of the movie. So if something goes wrong, how do you handle that? So let's do something like this. We're going to improve our success and our failure objects. So we'll introduce like an and-then method. So if you've done promises in JavaScript and you chain things together, you do a thing, and then when that returns or it succeeds or whatever, you do this other thing. So in both of the and-then methods, we give it a callback, which is just a block. So we've got that syntax there, and callback. It just means we're capturing the block. So you can just call yield, or you can capture it, which is what we're doing here. So in the case of success, that's cool. We want to carry on. It all worked. We got a result back. Let's take that result and give it to our callback when it runs. In the case of failure, it's a different story. When we call and then, we give it a callback. We actually just ignore that callback. We don't do anything with it. We don't call it. It just disappears. What we do instead is we just return the failure object itself. So this means we can do code that looks sort of like, actually, one of the things we get to quickly is just the import summary we change as well. So that's got an inserted, updated, errored, and that lets us more easily work with that thing. So with the and then, we can change our code to look something like this, which is a lot nicer and cleaner. So really what we're doing here in our import, first we fetch the credits, and then we get a method called pass credits, which we'll talk about in a second. If that works okay, we're going to call that method, and that's the thing that passes the JSON. If that all works, then we take the credits that come out of that and we give it to this next block, which is going to take the cast value from there, which is a list of all the cast entries, iterate over that using reduce. So we're going to start it off with an import summary that's initially empty, and we're going to call create or update title for each one of those things in there. And create or update title is going to update the import summary and return it back. So reduce is like an enumerable method on an array or some other data structure. It'll just step over each thing, but it'll give you an initial value, and then when you call the block, it's going to use that return value from the block to carry on. And finally, we call .then, and we've got a final summary, which is our import summary, all done, and we return a success. So .then is an interesting one. It's different to and then. And then is our special magic that takes a block and a thing, unwraps it, and gives it to the block. .then is just on object, and it says, take the object and put it in the block. So it means we can chain them together this way. We could rewrite this code by just assigning that to a variable at the top when we go into the top level, and then create success new off that, but this reads a little bit cleaner. You've got a step of things going forward there. So there's a question here. This was copied from not T-Hanks Overflow, but Stack Overflow. So our celebrity was hacking code, and they're like, I don't quite understand what this is doing, this and method full colon pass credits. What is that? Like, wait, what? So let's dig into that a little bit. So let's forget about that for a moment. Let's talk about a simple method. We can all kind of understand this. So we've got a square method, takes in a number, multiplies the number by itself. So square 4 gives you 16. If you've got a map of things, 1, 2, 3, 4, it'll calculate the square of all those. So 1, 4, 9, 16. I think we're all fairly comfortable with that. We can change it around a little bit. So say we've still got our square. Let's actually capture that. So we create a squarer object, which is calls method, which is a built-in thing in Ruby, and we give it the name square, which will grab like an object representing that method. And we can call that like a block, or a lambda, or a proc, or what have you. And if we wanted to map over it, we can explicitly do that. So we could create a block over our map and then just call squarer, or we can do ampersand squarer, which will take that thing and turn it into a block that can be passed to a method like map that takes a block. And the ultimate way that we're getting to is skipping all those intermediate steps. We do and method, which will take the method called square, the ampersand at the front turns it into a block, and we can give it to map. So this is a much easier way to actually grab things that we want to pass to blocks. And that's what this code here is doing. That first bit there, we say fetch credits, and then we're just grabbing a reference to the method called pass credits, and we're turning it into a block, and then we're giving it to a method that takes a block. So what we're doing here is nice. We can think about the happy case, because we're wrapping up the success and the failure in a value rather than some kind of effect that happens. And we can just ignore that failure path, and that'll bubble back up, and whoever called it will get a failure object, and they can do what they want with it. So we've cleaned this up, and we've kind of taken away some of the side effects. Well, we've taken away some of the error handling, but the side effects are all still in there. So we need to get rid of side effects from the framework as well. So one of the things we want to see is real things that we can't see. We want to pull them in there. So it's a little bit abstract talking about this. But what we want to do is create what's called an imperative shell functional core. So we have two layers to our code. The top layer, the imperative shell, is where the world interacts with our code. That's simple, but it provides services like doing stuff, writing to the database, that sort of thing. The functional core itself does all the work, but the functional core is not allowed to talk to anything outside, no side effects. What this means is that the imperative state is all handled at the top level. The business logic all gets pushed down into the bits that are much more easier to reason about and test. The shell's very simple, but it provides all the effectful things like reading from disk, reading from the network, getting random numbers, getting the current time, that sort of thing. But it delegates to the core to actually do the work. The application as a whole uses the shell. And again, the core does not do any side effects. Not allowed to change things, not allowed to mutate state, not allowed to do any of that stuff. So no I/O, no random, no current time. It's got to be pure, as in like you call this thing multiple times, it does the same thing with the same input every time. It's stateless, there is no data maintained in there except for data that's explicitly managed. And it's immutable, so anything that does go in there does not get mutated. What goes in gets unchanged. Things that come out, we can rely on them not being kind of having a reference somewhere else and being yanked around and all changed up. So there's a whole bunch of really good talks on this. Gary Bernhardt did a really good talk a while back called Boundaries about this. And there was also a screencast called Functional Core Imperative Shell that goes over pretty much exactly this. I think it was taken like a Twitter client that was created on the command line. It was all like mutable state, just stuff chucked in there, and refactors it to this pattern here, which is taking this core, which is functional and easy to test and easy to reason about, and then wrapping that in the shell that is going to talk to the world. And there's also a thing called hexagonal architecture. Another name for that is ports and adapters. And that's a similar thing where you have your outside world, which is all the ports, so everything that can talk over a network or talk to disk or read the current time. That all happens on the edges of the system. Then you've got the internal bit, which is the same ideal. It's like the adapter into your actual business logic, which is nice and pure and easy to reason about. So what does that look like in our code? So we'll split our single class that we had before into two parts. We'll have a credit importer shell and a credit importer core. So the shell is the thing that talks to the database. It reads stuff over HTTP, and it gives services to the core. Now, our initial approach, we're going to do it this way. So we're going to use our method again, which our friend, to grab a reference to those things, to turn them into an anonymous function or a lambda that we can pass in as a reference into our core. So we grab the fetch credits, which is the thing that's going to talk to the HTTP API, and we grab find title, which is the thing that's going to query the database, and we give those things to our core when it runs. And our core is going to look like this. So we've got our fetch credits, our find title that both get given here as arguments into the call method. And we use, so we'll call fetch credits, which will go off to the network, do its work, give you back some stuff, and then pass credits, and then import credits. And import credits will then go and do the work to write things into the database. So we haven't factored out that writing yet. That all still happens in there down in the create or update title. We'll get to that in a minute. So another interesting thing that's going on here is we've got and method, import credits, curry, import summary, find title. It's like, okay, that's an interesting thing that's happening there. What does this mean? So stepping back from there again, let's go back to a simple example. So add, I think we can be comfortable with this code. You take a method that gives you an x and a y, just add them together. So add 1 plus 2, you get 3. Let's get a reference to that and call it an adder using our method. And we can call that. So adder, if you do the dot syntax for calling a block and give it 1 and 2, it's the same result, adds 1 plus 2. Okay, that's cool. What if we only want to specify one of those arguments in there? We don't want to actually pass that whole thing in. So it's going to look something like this. Let's create an add5 function. And the way we implement that is let's just build a block, and we'll call the adder, but we'll hard code the 5 in there. And the x that we pass in gets passed in. So if we call add5 with 2, you get 7, because 5, which is hard coded, plus 2 will give you 7. If you added 3, you'd get 8. So that's one way of defining that. Curry is the same thing, so that gives you another way of defining exactly the same thing. So we've got our adder there that we've defined, which is just going to take 2 arguments, an x and a y, and we call curry on it. And what that will do is give you back a function that takes no arguments, or takes 1 argument, or multiple arguments. And what will happen when you do that is if you haven't provided enough arguments, it'll give you back another function. So it's a higher order function that will return another thing with those arguments that you specified pre-filled, so let's put them in place there. And that means that you can then call it. So in this case, we're saying adder, which has got 2 arguments, curry, and we're going to fill in 5, which is the first argument. That's a thing that's going to have 5 hard-coded in the first place. If you call that thing with 2, then you get the answer. So 5 plus 2 is going to give you 7. And we can use our method syntax by our method for grabbing a reference to add and doing curry that way. And that's a nice shortcut for doing those things as well. So this is what we do here. So why are we doing this? When we get to that point there, to get a reference to that import summary, and then we'll pass 1 value through. So we've also been given other things that we care about along the way. So we've got an import summary that's been given to us by the shell, and we've also got find title that's been given to us by the shell. But we're going to curry our import credits method to essentially hard code those things into there, and that's what we give to and next. So when and then runs, it will call import credits with the import summary and the find title helper method, or helper function that talks to the database. They're hard coded in there, so it's really turning it into a function that used to take 3 arguments and now takes 1, which is just the credits object itself that came out of the JSON. So it means we can call a thing that's got 3 arguments with just 1, which is nice. And we do the same thing here as well. So in our reduce, instead of calling explicitly. So we could define a block here, which is what you usually do with a lot of enumerable methods. When you call them, you're going to say, all right, I want to iterate over these things, and here's a block that I'm going to call on each iteration through this thing. A block doesn't have to be passed as a block. You can just take an anonymous function that we get by calling method, and then we carry, define title, helper, and that gives us a thing that we can pass to reduce, because it's got the same thing. So reduce wants to give you an accumulator and the current value that we're iterating over. So create or update title looks like this. It takes 3 arguments: find title, import summary, and cast entry. So import summary is really our accumulator. That's what gets bumped up each time we run through. That's our result that we want to return back. The cast entry is the current iteration through the loop. Find title is just a hard-coded thing. So that's why we carry it there, because we can just inject that in and then treat it as if, even though it's 3-argument function, we only need to call it with 2, which is what reduce wants. So they've plugged together. Finally, then we return the success again. So this is cool. At this stage, we have removed the effectful code from the functional core. The imperative shell is injecting that stuff, which is cool. But we've only done the read side of X so far, so we want to pull the write side of X out too. So how do we pull all the side effects out? I asked our person how we do this, and he wanted to eat a crab. So how do all the side effects come out? It's kind of simple. Just carry on that pattern. So instead of just injecting the fetch credits and find title, we also inject insert title and update title. Then when our code runs, we pass all those things into it, and if we're doing, if the title exists already, we do an update title. So that's not actually talking to the database directly there, but what it's doing is calling a function that we've passed to it. That means we can stub that out for testing, because rather than directly talking to the database, we can just give it a function that's going to go and update the item or insert the item. And then another one for defining the title. This makes it much easier to work with. Which is cool. We've extracted side effects now, but we haven't. All we've done is abstracted them away. They still happen at that point in time in the code. When the code runs, it's still going to talk to the HTTP API, it's still going to pass JSON, it's still going to read the database, it's still going to insert or update the database. That hasn't changed. We've just changed the way that we've set that up and provided it to our code. So we want to not do that. So let's escape doing that thing as well. So how do we actually turn what's happening in the world into actions? So we want to separate defining a thing from doing a thing. And what we want to do is return values. Instead of actually doing the thing at a point in time, let's just return a value that represents that thing. We can do it later. So for our insert title, we're going to create a new value, and that's just the attributes that we want to insert for our title. And for the update title, we've got an existing title record, and we're giving it the attributes we want to update. And in our code, that's all we're going to do. We're just going to create that value. So in our create or update title, rather than actually doing the database operation there and then, we just create a value, and that's what gets returned back. And it also means our reduce operation over everything needs to change. So when we iterate over our cast entries, rather than just doing the thing there and then and being done, and it's like, hey, side effect's done. I don't need to return anything because I did a side effect. We need to actually capture these things and put it in something. In this case, it's going to be just an array that we're going to return back to the caller. Then when it goes back to the caller, it's going to have an apply method on here, which we call. So again, we're using and then, so if it all worked, this gets called. If anything failed along the way, nothing's going to happen, this doesn't run. But the apply function will then go through and step over each of those actions that we've generated. So that could be multiple. So say we've got hundreds of cast entries in there, there could be updates or inserts, a whole list of stuff to happen. And we're going to step through and work with that. And kind of the nice thing here is we're using the new Ruby 2.7 pattern match syntax. So if you look closely, we're doing case, action, and then we use in. So usually you use when in older ones there, but it means we can pull values out of, or we pull fields out of each of those values and then use them directly. So just, it's a little nicety. It removes an extra layer of direction in there. But what we do is just say, as we loop through this, if it's an insert title and we're applying it in our imperative shell, then do the database operation. If it's an update, then do the database operation. We're not doing the database in our functional core, we're just returning a value representing what we want to do, and that is what happens in the shell. Which is cool, so our functional core doesn't change the world anymore. We're just returning all those values as a list of actions or effects to be done, and then the shell takes care of doing that. Still got the read side that is talking to the world though, so we need to look at that. So let's escape that bit of the framework too. So how do we get rid of read effects? So read effects could be trickier than writes. So how do you return something that you've already had to execute to do a thing that you're returning anyway? So in terms of like fetching credits, you can't return that we fetch credits because you have to have done it. Otherwise, you can't do anything else. So let's take the same approach, put them in a value, but instead of just leaving it there, we'll give it a next field as well. And that next is going to be another function to call when it runs. Then we can pass that back up from the functional core to the imperative shell. The imperative shell can take that value, and then when it handles it, it says, oh, you need to do a read here. I need to fetch credits from the movie database. I'm going to do that. Then when those results come back, then it calls the function that you've given it in the next position. And this can go and chain multiple levels through there. So you can have all your reads going through that way. So that'll look something like this. So we want to have more values for our effects. Okay, so our fetch credits, we've got all the stuff hard-coded in there, so we just need to return a value saying, yeah, we want to fetch the credits. We don't give it any parameters, we just give it a next thing, which is the function to call after the parameters come back. With find title, we give it an ID that we want to look up. When it goes and looks up the ID, it'll get that title from the database, and it'll be an active record object. It'll give it to the next function. Same with insert title, we're going to insert stuff, then do something else potentially. Update title, we want to do something with the title, put these attributes in, then do something else. With empty, it's a placeholder, so we can kind of start a chain. And return is a special thing that we'll get to in a moment, but essentially it means we're at the end. I'm giving something that I want to pull out, and that's what eventually gets returned when the imperative shell executes all this. And we've got a helper function in there called pure as well, which really just takes a result and puts it in a return object, which we'll get to in a minute why we need that. So back to our and then approach again. We've got a whole bunch of things that have a next field. So we want to do something with that next field in an easy way rather than having to manually define like nested objects, because that's going to be a mess to actually construct that stuff. So we'll have this helper method, which gives us an and then, which we give a block to. And then it'll kind of create like a copy of the current value that we're working with, but it changes what the next operation is to be another function that calls next and then recursively calls and then on that. So I don't have to think too hard about what this does, but basically it means if we have an effect that we want to run, we say and then do this after you return a result, and then you can chain them multiple times. So we can say fetch results and then do this, find title and then do this. And then we can just include that into all our effect values. The only difference is going to be in the return, where we don't want to chain a thing. We just want to call whatever our block is and then return the result back out again. So to run this, this is what our functional core code turns into. So we've got a call, and instead of calling the fetch credits callback we got given, we're going to create a new fetch credits value and give it a lambda function, or like you can think of it as a block or a proc, but basically it's an anonymous function that we can pass into there. And that's what needs to happen after the credits come back. So what the intent is that when that runs in the shell's going to say, fetch credits, cool. I'm going to go and talk over the network, grab the HTTP response, package that all up, put it in here, and then pass it to the function that you've given me, which will take the credits JSON, then call pass credits on it, and then we want to get the method to pull that out and then import the credits. Likewise, when we create or update a title, rather than actually doing a thing at that point in time or returning a value there, we're still returning a value, but what we're going to do is actually chain them together. So first of all, we define title, And then once we've found the title, we go in and we either update it or insert it. In our imports credit in the middle there, that's where it gets interesting because we have to track the previous thing. So we start off with an empty value, and then each time that it iterates through, we get the previous value as the accumulator and the current cast entry that we want to insert into the database. And what we do is we take the previous entry and we say, and then, after you've executed that previous one, do the current one, which is what our creator update provides. So what this means is that rather than returning a list of things, we're returning a recursive data structure effectively. So at the top level, it's going to be an object with a next that will be a function. You call that with a value. You get another thing that is a value with a function. You call that, and you call that, and call that, and call that. And that's the way that this thing will be run. So it's not actually a data structure you can look at. It's a data structure where the data is contained within a function that the thing owns. So once we've run that, then our shell changes to look something like this. And it turns into a big switch statement, effectively. So we've got our case on our action as we run through. So we just get given one action back. We don't get given a list of action. We just get one at the top level. We call that, and then the block that we've given to it, or the anonymous function, will figure out what to do next, which is in the next value. And this is what we do here. So let's just do a case match on the action. If it's a fetch credits, go off to the internet, grab the credits, pull them down, and then give them to whatever the do next thing is, and recursively do that. Likewise, if it's a find title, go to the database, pull that out. Once we've got the result, call the next thing, give it to that, call that function. Inserting a title, same deal. Write the thing to the database, call the next thing. Update, call the next thing. Empty is kind of just a placeholder that we need there to start that reduce chain off. But the special one is return down the bottom there. If we get a return, that's what we bubble back up. That's where our result comes from. So what we've done there is actually just built like a mini programming language and an interpreter. So the functional core is not actually doing any side effects at all. It's just returning a data structure that is really an abstract syntax tree to run a program. And then the imperative shell is really an interpreter that takes that program and executes it. It goes to the world, it talks to the database, talks to the internet, does the side effect things. The functional core is not doing any of that. It's nice and contained, and isolated and simple and testable. So by putting the reads in a value like that, this lets us do that. So you can chain them. In fact, you have to chain them. But that API is kind of clunky. If we look at that, it's not that readable. Like, I don't quite know what's going on there. It's kind of weird. If I check that into a code base, someone's going to say, no, that's not Ruby. So we need to make it nicer. We make it nice. We need to be Ruby, so Ruby is nice, Mats is nice. So our nicer API is going to be really this. We just define a bunch of functions that construct those things for us. So we have a fetch credits method that will just build a fetch credits value, and it gives it pure as the next thing to do. And what pure does is just says, yeah, give it back to you, whatever's in there, give it back. Not going to do anything else. Same for all the other ones. So find title, insert title. We've got a nice, simple API. These just take like the value that's going to run. It looks very imperative, very Ruby-ish, very easy to think about. And when we put that in our core, that actually turns into something that looks almost like normal Ruby. So in our call method, we fetch the credits, and then pass the credits, and then import the credits. And then when we find or create them, we find a title, and then we update the title, or the insert a title. This becomes like really easy to work with, like really like a fluent API that is not too bad. So our actions, yeah. Our shell has got a bit of logic in there, that's okay. But compared to our initial thing, yeah, it's a lot better. Like, I'm liking that a lot more. It's a lot testable, you can work with the thing. Much better. So the bonus surprise here is we've actually built monads the whole way through. It's a dirty M word that people get freaked out about, but really it just means here's a thing, and then do another thing afterwards. That's all a monad is. So that's chaining it. If we want to chain those things together, it's a success. That's like a result or an either monad, depending on the language you're in. And we've built a list of effectful values. That's a free monad. Another word that people kind of get excited about. There's a really good talk by Matt Parsons that I completely ripped off to do a lot of the free Monad part stuff of this. Go and watch this because he goes over it and talks about it in Ruby and the same code in Haskell. The nice thing with Ruby is that Haskell gets very formal and very precise around how these things are defined. If you want to do this in Ruby, it's more casual, more laid back. You can just make it work, and that's cool. And that's me. Thank you for your time. I hope we all escape the framework.